Chris from Menlo Micro, and he's going to talk to us a little bit about some solid-state relay technology, where something that would fit on the end of my finger will replace a relay about this big. Chris, what have you got here?
So what we're presenting here at APEC is our technology that we've trademarked as the ideal switch. And what it essentially consists of is our mission is replacing relays, both mechanical and solid state relays that are used for a whole host of applications for industrial controls, home automation, transportation. There's over 20 billion relays that are sold every year into a variety of different power electronics applications, and so the ideal switch is intended to provide a better solution for those applications where people are using power relays.
I see, and it's a basically a mechanical technology, but it's on a chip.
Yeah, so people are probably familiar with these types of larger mechanical relays that use a coil. You drive a coil that will force a relatively large piece of metal to move between two contact points to connect the circuit. We use a similar concept, except it's done at the micro scale. So our switches are only 50 microns by 50 microns in size, but it's still a mechanical actuator. So it retains a lot of the electrical properties of a relay in that you have a metal-to-metal contact when it's closed, so it's very low loss, and when it's open, you have an air gap. So it provides for very high isolation, but extremely small.
So the actual arms of the relay are still metal.
Yes.
How do you get them that small on a chip?
Well, that's the magic, and that's the process that this technology was initially developed starting back in 2004 at General Electric. And the reason that GE was getting involved in the space was actually to create micromechanical circuit breaker technology. And so all the materials that are used, as well as the process for putting down those materials to create these very miniaturized mechanical actuators, and to have them be able to open and close reliably billions of cycles. It's part through the design, it's partly through the materials, and then also in the processing in the wafer fab.
So these teeny tiny little actuators, when they're handling DC, how do you avoid arcing?
That's a good question. The design that we have is very unique in that the switches are packaged in a hermetic environment, and the design is such that we do not arc across these very small gaps that we have. So yeah, it's basically built into the physics of the. It's sometimes counterintuitive that by miniaturizing you can actually eliminate some of the arcing concerns. But yeah, it's an arc-free technology. We can actually stand off 200 volts across a miniaturized, very small gap. And when we want to support higher voltages, rather than moving the conductors further apart, we have a process where we can stack these devices in series, and then we can balance them such that we can hold off higher voltages in that way. So yeah, it's an arc-free technology.
Sounds like a neat trick. So where can our viewers go to get more information on it?
There's all of our data sheets and information is at menlomicro.com. We have for both our RF existing products and some of the new products on the power side, evaluation boards, prototype kits, design files, simulation files, all that is available on our website that we provide to customers who are designing with our technology.
Great. Thanks, Chris. That's interesting stuff.
Great. Thanks for having me.